Okay, our next presentation is from Shane Boone with Bridge Diagnostics Incorporated. Shane Boone is a PhD, Vice President of NDE at BDI, has spent nearly 15 years in government, academic, and private sectors of specialized infrastructure, inspection, and monitoring. He specializes in the research, development, and application of non-destructive testing and evaluation technologies and monitoring for civil infrastructure. Previously, Dr. Boone has managed NDE programs at Federal Highway Administration and Oak Ridge National Laboratory. He serves as the chair of the American Society of Non-Destructive Testing Structural Materials Technology Conference, a chair of the ASNT Infrastructure Committee, and sits on the TRB's Field Testing and Non-Destructive Evaluation of Transportation Structures Committee.
Thank you for the introduction. So as he said, those of you guys that don't know me, I've spent about 15 years trying to figure out how to apply this stuff. I was 10 years at Oak Ridge National Lab doing acoustics and electromagnetics, and then I went to Federal Highway and started doing electrochemical and more acoustics and electromagnetics. And over the last 15 years, it's been, well, how do we really apply this? So this is kind of what this talk is about. It's a little bit of policy, a little bit of technical, so I hope I don't bore you too much. To talk about what I'm going to talk about, about a year ago, Ted Hopwood did a survey of all the states to determine what they were doing with regards to NDE on steel bridges. And then about 2 or 3 months ago, after learning that I was going to give this talk, I did a similar thing, but it was much shorter, 5 questions that went out to the states with regards to NDE of bridge decks. So I'm going to talk a little bit about that, talking about the existing problems that I've seen at state DOTs. This will be my 7th bridge preservation partnership in the last 2 years, and next month I'll make it 8. So I've gone to all 4 in the last 2 years, and along with individual state visits, I've talked to a lot of states about what they see, primarily with bridge decks, just because that's what I've tried to make my specialty in non-destructive testing of bridges. So I'll talk about those problems that I've seen, and then basically what I've identified as a phased approach to efficient deck rating, and it's going right in line with what Maryland's doing. So it's good to see that states are starting to adopt these technologies. Then a short proposed implementation, and then hopefully we'll have some time for questions. Like I said, Ted put out a survey it was about a year ago. It was multiple choice. He had 17 questions. He got 27 state responses. And although it was mostly steel, he did get some information that's relevant to bridge decks. So I'll kind of include a little bit of that. Mine was a little bit more pointed. It was open-ended, so it was kind of like, you tell me what you're doing, and we'll see if it compares to anybody else. It was only 5 questions. I got 20 state responses, which I considered pretty good, considering Ted got 27. So I'll talk about those responses. So I don't want to go over Ted's questions because there were 17 of them, and I don't want to read all 17 to you guys, but I will read these 4 because I think they're important to what I'm going to present later. And the questions were fairly simple. It's what's your state's existing procedure for in-depth inspection? Chain drag, coring, whatever. What's your state's existing procedure for determining when you should do an in-depth inspection, and or what bridges should be done, and when should you do it? If you do NDE, what methods are you currently using? And if none, just say not applicable. And if your state does not do NDE, why not? Hesitancies. I actually said horror stories. Luckily, I didn't get any back, but that's not to say that there weren't any. And I got some pretty good results, but overall, and I don't, like I said, I don't want to go through each individual response, but overall, states, when they do in-depth inspections, they do chain drag and sounding. Those were the most commonly used inspection techniques for in-depth deck inspection. Some states did do chlorides, but overall, it was mostly chain drag and sounding. And I know that I'm not telling you anything you don't know, but just so you know that other states are doing this. Most states did not have an in-place procedure for determining when to do those in-depth inspections. Most were consistently based on the age of the bridge or a poor visual inspection, something that had to do with a bad MBIS rating. So they would go back and say, okay, we need to do this in-depth inspection. 90%, this actual quote came out of Ted's survey, 90% used after the discovery of probable anomaly during biennial safety inspection or arm length visual inspection. Of the NDE that was used, most commonly it was GPR and infrared. 45% of the respondents actually said they didn't use non-destructive testing at all. Impact echo was mentioned sparsely, kind of to compare to chain drag or sounding when they were out there, or to try to correlate to the chlorides. And then the reason that most states did not use them was actually not for bad results. That did come in there as a lack of correlation between results and chaining and lack of experience using it, but it was really a perception of the high cost. So, in the last 5, 10, 15, 20 years, the cost of these types of services has dramatically changed, and some states still have the perception that it costs an arm and a leg to do these types of services. So, real quick review, most states chain drag. In-depth inspections are based on age and visual inspection results. Most states that do NDE is GPR and IR, and the reason that they typically aren't using it, if they're not, is perception of high cost and or poor correlation results. So, as I said, I've been going to a lot of state DOTs, and outside of these results that I got from the survey, I've also heard two of the same similar phrases, and I paraphrased these. But these are phrases I've heard over and over, and the phrases are, it seems like recently research is performed to advance the technology without ever really asking what the problem is. And it's what problems are the state DOTs facing, rather than just going out and making this advance in technology or that advance in technology, some type of automation or some type of robotics. What can really help the state DOTs? And then the other one that I've actually heard at a lot of these TSP bridge preservation partnerships are, why would you apply an overlay when you don't know what's going on beneath the surface? So a lot of these visual inspections come back and they're fine, but we identify that through GPR or chlorides or coring, that there's actually a good bit of deterioration going on beneath the surface, and by applying an overlay, you're just trapping that inside the deck. So what's the real problem? And we all know this, we've all seen this slide and these charts, but 30% of our infrastructure is over for 50% of its design life. In 2013, we had a $121 billion investment backlog. We needed an extra $8 billion annually, and basically there's just not enough money to do the inspections and maintenance and repair like the states want to do. So there's just insufficient funds. In 1971, NBIS came out, we had plenty of money. Gas tax was okay, higher relative amounts of funding. Infrastructure wasn't really that old. It was 50 years younger at that point. Now we have insufficient funds, with less funding, much less, and the infrastructure is degraded. So what's a proposed solution for this? Well, the proposal that I'm making, and that I think states are starting to adopt in one way or another, are to perform screening techniques so we identify when we actually need to do these inspections. And Glenn Washer has done studies through NCHRP to identify risk-based inspection, and we're hoping that those will start getting put into the legislation. But in order to do that, we still can't go and inspect every one of our bridges with non-destructive testing. So that's not what I'm proposing. I'm not saying we go out and we do an in-depth inspection of every bridge with impact echo or ground coupled GPR. I'm proposing that we do identify which bridges need that in-depth inspection through these screening techniques. And we collect that quantifiable data, and then we create this risk-based inspection matrix and a new asset management program. And when we perform these project level inspections, maintenance and repair, we do them as needed rather than just based on the age of the bridge or these somewhat qualitative methods that we've used in the past. There's lots of options for this. It's not just what I'm going to be talking about today with regards to bridge deck inspection, but we've all heard lots about drones, and I think that unmanned aerial vehicles are going to be coming up and moving and helping us with these inspections. There's video-based systems where we can do visual image correlation to identify what's going on with our bridges. Sensors and structural monitoring, scanning, like I'm going to be talking about, and then there's others. So, with that being said, I'm going to jump into what I consider one of those approaches, and it's a phased approach to bridge deck inspection. So it's a fairly simple theory. You use high-speed deck scanning to quickly evaluate and screen the bridges in a safe manner and an efficient manner, and I think you guys kind of went over that very well. It not only provides you data efficiently, but it also provides you data safely. So you don't need to be out there closing down the lane, having your inspectors out there on a bridge deck. You use the quantitative data to determine which decks actually need to be programmed for project level work. So if you've got a bunch of bridge decks and you don't know really what's going on, and you're going to program them based on their age or based on a visual inspection, this allows you the opportunity to do that with a quantitative set of data. And then you accumulate this data over time, and you start creating network level life cycle analyses, models for your bridge deck inspection and replacement, and you can go ahead and get it into that element level condition rating using the quantitative data if you correlate one to the other. So a simple phased approach, you would use high-speed deck scanning with GPR, infrared, and video. The phase one deliverables would be fairly simple. They'd be draft condition assessment reports, so you could go out there and identify which of your bridges you needed to do on a network level inspection. So you'd have concrete deterioration, delamination, patches, and spalling, and overlay covers like we've heard about today. And then once you had that data, you could identify which ones of those bridges you wanted to go through and do a project level inspection, and you could do that for validation of the data, high level resolution inspection, so correlation to chlorides, and then you start developing this asset management and risk-based inspection modeling protocol so you can identify which ones of those parameters actually affect your bridges the most. And so that you get it more and more data, you can start correlating it back to these high-speed deck scans, and so you don't even have to do as many of the project level inspections. This specific approach would propose a high-speed inspection technique. You could use singular step frequency GPR like the folks at Maryland are using, or an impulse GPR. I think it's more a preferential type thing with my experience. Some systems are a little bit more efficient than others. Some systems are a little bit more expensive than others. At the end of the day, you're getting very similar data if you're scanning at a high speed, and what you're really looking for there is the opportunity to gain enough information that you can determine which ones of your decks need to be thoroughly inspected. Multiple wavelength or extended exposure infrared. At ASNT conference a couple weeks ago, we heard a lot of different talks about high-speed scanning versus long-term exposure infrared, and both provide different opportunities and different benefits. And then up to 4K HD video. So combining these approaches, combining infrared and GPR gives you allows you the opportunity to inspect not just for shallow delaminations, but also your deeper delaminations. And having that HD video allows you to not necessarily replace the NBIS, but supplement it and augment it. So your bridge deck inspectors can go out, and they're already going out there anyways and taking pictures. Why not take a 4K video? I don't think that if I'm looking at a computer screen and I can zoom into a 4K video, it's probably better than I'm going to get out there on my hands and knees with a magnifying glass. And I know that for a fact I don't want to be out there doing that. So it just gives us a safer option for our inspectors. We've talked about it a little bit in this past presentation, but just analyzing this data in GPR, there are automated fashions to do that. Because we're looking at a difference in dielectric permittivity, we do see migration of the data and attenuation of the wavelengths as you get these areas that are starting to lose some of the cross section and have deterioration. Now, whether or not that's actually an indicator of a delamination or a precursor, that takes a little bit more data, and so we want to go through and do our project level inspections and validate that data. But this does give us the opportunity to take specialized software, geospatially locate it, and identify areas of our bridge deck that are deteriorated and be able to tell us what the percentage is. Now, if it's a difference between 85 and 95% because I'm using air coupled versus ground coupled, I think that still gives the state the idea of, well, I need to replace this deck. Or if I say, well, you've probably got about 5 to 10% DLAMs versus 45 to 50% DLAMs, it gives them an idea of, okay, I need to do something about this deck versus this deck will probably last another 5 or 10 years. Infrared, very similar thing. We're geospatially locating everything, and it's given us the idea of whether we have short delaminations, shallow delaminations. And what we can do is combine these results and look at a very, very pristine photograph. If you'll notice, you probably can't see it, but this is over 500 feet of bridge deck. You can zoom in, it's 4K. Same thing with the GPR and then the IR. These little red circles correlate pretty well. On this deck, I think you'd probably maybe do a spot inspection or a spot replacement or something like that. It's nothing like here where it's very clear that it's probably time to replace that deck. But without scanning those, in the current practice, you would have to go through and do a full chain drag or whatever your state tends to do on an in-depth inspection. So this just would go through on a phase 2 inspection. You would essentially take your phase 1 results and then start collecting some of the really high definition data, some of your chloride measurements, impact echo, getting a feel for how the high-speed deck inspection correlates to what's really going on in your deck. Are you missing it by 5%, 3%? And then you can start building models and parameters on, is it my chloride that's affecting the life? Is it the cover? And you can start putting all those parameters into this life cycle cost analysis, life cycle benefit, and saying, okay, well, if my deck's only got 2 inches of cover, then it means that it'll last X amount of years, versus if it's got an inch of cover, it's only gonna last 3 or 4 years. And you start building these parameters, and then you identify that you can use the data that you're getting on the high speed and plug it into this model that you've put together on the project level, and come up with some really good results that give you an idea, scanning your bridges, which decks need replacement, which decks can last a little bit longer. And the objective there is to just keep people off the bridges, do it quicker, do it less expensive, and have more money at the end of the day. So the proposed implementation would be performing screening on a high population of decks, identify thresholds for performing the project level inspection, determining modeling parameters that correlate the screening data, so the high-speed stuff, to the high-resolution inspection. And then once you have those correlation parameters set, using the high-speed or the network-level inspection to determine element-level condition ratings. So we already know what these element-level condition ratings are. We know what the condition states are. We know what those element-level definitions are. AASHTO identifies them very clearly for us. And we've got technology that can do that. Where we are, we're performing high-speed deck scanning now. We can perform high-resolution deck inspection with HD video, and we can compare and correlate the factors that we're modeling between network and project level. Where we can go, we can start automating these, and it looks like Maryland's already doing that, and that's great news. But we can automate the crack detection with HD video, which gives us a link right back to our element-level condition rating. We can automate delamination mapping with GPR and IR and other methods, high-speed acoustics, which are coming along. The automation of the GPR and IR data is fairly well coming along, and several companies out there are doing that now. And then we can start directly correlating quantitative measurements with these element level condition states and speed up everything. So we speed up our inspection process, we speed up our rating process, we speed up the process we take to decide which bridges need repair. And then by doing that, we have enough time, enough money to start funding more the maintenance and repairs and replacements that we need. So it's basically doing more with less. So in conclusion, I hope I haven't run over, I have no idea. Most states are typically using chain drag or sounding to perform in-depth inspection of their decks. There's a hesitancy to use NDE based on lack of experience, perception of high cost, and poor results in the past. The primary problem that states face is a lack of funding to do the work they do. And there are screening technologies that can assist states in implementing risk-based inspection protocols and improve asset management. So essentially, we've got these options, not just the deck inspection that I'm talking about, but all these other things that we can do, structural monitoring and drones and all these technologies that are at our fingertips to really improve that risk-based inspection options that we have. One such option would be high-speed deck inspection. We can perform that on a network level, identify what parameters need to go into a project level inspection. We can start correlating those so that the data can be used to determine and eventually automate element level condition ratings for bridge decks. Acknowledgements. I wanted to acknowledge Ted Hopwood from the Kentucky Transportation Center for providing his survey results. All the state DOTs, state highway agencies, and departments of roads that participated in both surveys, and InfraSense Incorporated for providing the bridge deck ND results and pictures that I used in the presentation. With that, questions?
We've got a few minutes for questions.
Okay, so questions. Siva. Well, so I would always argue that if you have the opportunity to use one or more non-destructive testing technique that you should. If nothing else, to correlate the two to make sure you're getting a good value. So if I'm using GPR, you are right that GPR will provide pretty good results in identifying deterioration. But what we've learned recently is that GPR can over-predict the delamination simply because it's using the dielectric of the material, not necessarily whether there's an air gap there. So the steel could have started corroding, but we don't necessarily have a delamination yet. So the GPR could pick up a delamination, whereas the infrared would not. So while they pick up the same thing, you're right, and infrared is more difficult due to times of day, and there could be, a spot on the road or whatever. We want to use both methods so that we ensure that we're not picking up something that we think is a delamination that actually isn't. On the infrared, the reason that we also compare it and add HD video is so that we can see those areas of the deck that have big blobs of oil or a shadow or something like that, so that we say, oh, that's apparent in the visual spectrum of light, so we want to exclude it from our IR. And then obviously we want to do scanning at multiple times a day to ensure that we get all the right data, make sure that we're not scanning during a heat equilibrium time or something like that. Does that answer your question? Okay.
I'm thinking about the human condition, and you got, some states which are far ahead and well versed with these technologies, and other ones which are not. And how much, percentage-wise, how many are really there, and how many were just so afraid of it that it's going to take them 10, 15 years? I don't know. You know where I'm going with this?
I think so, yeah.
Like, how do you bring everybody up to the same speed so that you have this standard, this benchmark of reference?
So fortunately, that's not necessarily my job. My job is just stand up here and preach about how great it is. But the Federal Highway Administration, I think that probably is their job, and they are in the process of doing that through the SHARP 2 Implementation Assistant Program. So as we all know, SHARP 2 did several studies. The RO6 studies in general were on non-destructive testing. RO6A specifically was on bridge decks inspection. About 2 years ago, 8 states were awarded $100,000 apiece in implementation assistance funding specifically for RO6A to do bridge deck inspection. And then recently they did another round 7, that provided $30,000 to, I think, 10 additional states to start doing this. So the federal government is providing additional funding because, states already, like I said, don't have enough money, so why are they going to spend money learning something? They don't want to. And it's not that, it's not something they see as valuable. It's like, well, I've already got to do all these inspections and repair and maintenance. I simply don't have the funding. So SHARP 2 is providing some of that funding to do those types of inspections. And I think the hope is that once, these 18 states or whatever start coming to things like this and saying, hey, we had great results. We just saw a presentation by Maryland that said we're having great results using this, that other states start adopting it as well. So it's definitely not something that's going to happen tomorrow, but it is gradually coming on.
If I understand correctly, you're saying that we should also specify infrared in conjunction with the GPR?
What I would propose, are you a state DOT? I'm sorry.
No,
Okay.
consultant.
Consultant, okay. But the work is for a state DOT?
Yes.
Okay, so whenever I talk to state DOTs about doing bridge deck inspection, I always urge them to allow the consultant to tell them how they would best do the inspection. So some consultants will say just GPR, some will say IR. You're always going to get the best results if you combine different methods that are complementary. So in this case, GPR and IR are very complementary. Like I just said to Siva's question, one of the issues with GPR is that it has a tendency to over-predict delaminations because it'll pick up when you're starting to have a change in your dielectric permittivity based on your steel corroding. Well, that'll give you a difference in attenuation of your waves and could show up as a delamination. Well, if you pair that with infrared thermography, you're going to see that it won't show up in the IR spectrum, and so you won't get that over-prediction. So I believe that the pairing of the two is the best method. Did that answer it? Sorry. Okay. Ken?
There's certain situations where infrared may not be appropriate. For example, when there's an asphalt overlay, infrared isn't quite as appropriate. So a lot of decks in Connecticut have asphalt overlays. So in that case, you probably were correct in not including infrared.
Yeah.
But as Shane said, it might have been good to have heard that from somebody.
Yeah.
In
That's
the
a
process.
good comment, Ken. Yeah, infrared won't work on an asphalt overlay.
It's not as reliable.
Yeah.
I mean, sometimes it does, but
Right.
I wouldn't recommend.
Yeah, if you've got 6 inches of asphalt on top of your concrete bridge deck, it's going to be hard to identify delamming your rebar 3 inches further down. All right, Ed, am I done?
Yep.
All right, thanks, guys.